This video contains second and third gas laws. First one we're going to cover is Boyles Law. So Robert Boyle discovered that when temperature and the number of moles of gas remain constant, there is an inverse relationship between temperature and volume. And I'm going to open this graph first down below to show you what we mean by inverse relationship. If I've got pressure on the y-axis, volume on the x-axis, basically as pressure increases, the volume decreases in an inverse manner. And you get this inverse relationship, and it's the only gas law that's an inverse relationship. So to show this inverse relationship, the formula looks as follows. The initial pressure times the initial volume is going to equal the final pressure times the final volume. And I've defined those variables here. I'm going to give you a moment to take that down into your notebook, and then we'll move on to the next slide. All right, linearizing Boyle's Law. So, as I said in the previous slide, this is an inverse relationship. And if I want to make that inverse curve into a linear graph, what I can do is I can put pressure on the y-axis and the inverse of the volume on the x-axis. So this now turns the slope positive, and the slope will end up being a product of the pressure times the volume at a particular point. So that's what we mean by linearizing a function. When we do that, we can find the slope, and the slope will give us the constant, and in this case the constant's called k. So I wanted just to show you that because that's the only time we have to do this with these gas laws. This is for Boyle's Law. We're going to take a pause here so I can jump screen so I can show you your example. All right, we're back. A sample of neon this is an example of Boyle's Law if you haven't guessed. A sample of neon occupies a volume of 461 milliliters. We're going to call that V1 at STP. That means my pressure here is going to be 100 kPa. What will be the volume of neon? That's going to be my V2 I'm solving for. When the pressure is reduced to 93.3 kPa, that's going to be P2. So here's my Boyle's Law. P2, V2, and I'm going to fill in I'm going to rearrange my equation. Sorry about that. I'm going to divide both sides by P2, and that's going to isolate V2. Just like that. Remember, we isolate the equation, isolate a variable to solve in the equation, so I do not have to worry as much about sig figs. My pressure is going to be 100. My volume is 461. And my final pressure was 93.3. Another thing here, my volume being in milliliters is no big deal, because whatever volume units I start with will be the volume units I end with. So I punch all of this magically into my calculator, and paying attention to sig figs. By the way, this is a lit value, no sig figs here. I'm going to end up with 494 milliliters. Here's my double check. I decreased the pressure, so I should have increased the volume. And that I did. So I have solved this problem correctly. You're going to see at the bottom here some real simple Boyle's Law problems to hack out and make sure you get it. Good luck.